Consider two masses m1, m1 and m2, two different masses m1 and m2, moving with velocities u1 and u2. Let u1 and u2 be their initial velocities, collide like this. This is m1 and this is m2. After the collision, let the velocity of m1 be v1 and that of m2 be v2. So these are the cases. This one is before collision. Before collision, this one is actually they are colliding, and this is after collision. So three cases. Let u1 and u2 be the velocities before collision and v1 and v2 be the velocities after collision. So how will you find an expression for the velocity v1 and v2? And since the collision is elastic, we know momentum before collision is equal to this. This is the case of momentum before collision. This is the case of collision before collision. This is the case after collision. We have momentum before collision is equal to momentum after collision, which means m1 u1 plus m2 u2. This one is the total momentum before collision is equal to total momentum after collision, that is m1 v1 plus m2 v2. This is according to law of conservation of momentum. Law of conservation of momentum. Clear? Taking m1 to one side, you get m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Taking m outside, m1 into u1 minus v1 is equal to m2 into v2 minus u2. Let's call this as equation number 1. Also, the kinetic energy is also conserved. That means since the collision is elastic, kinetic energy is conserved. Kinetic energy is conserved, which means kinetic energy before collision, that is half m1 u1 square plus half m2 u2 square is equal to, what about the momentum, what about the kinetic energy after collision? The total kinetic energy after collision will be half m1 v1 square plus half m2 v2 square. Clear? You can cancel all these 1 by 2's, that is 1 by 2. Clear? I'm just erasing the first diagram in order to make some space. That is, this can be written as m1 into, taking the m1 to the one side, that is m1 u1 square, taking this m1 v1 square to the left, that is m1 v1 square is equal to m2 v2 square, keeping this m2 v2 square on the right and taking this one to the right, it will become m2 u2 square. This can be written as m1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square. Clear? So this will become a square minus b square is equal to a plus b into a minus b. So this can be written as m1 into u1 minus v1 into u1 plus v1 equal to m2 into v2 minus u2 into v2 plus u2. Clear? Call this as equation number 2. So if you divide equation 2 with equation 1, that is, if you divide these two equations, you will get m1 into u1 minus v1 into u1 plus v1 divided by, on the left hand side, this is m1 into u1 minus v1 is equal to, divide the right hand sides, that is m2 into v2 minus u2 into v2 plus u2 divided by m2 into v2 minus u2. Clear? Now you can cancel this m1 and this m1, this m2 and this m2. u1 minus v1, u1 minus v1 get cancelled. Similarly, v2 minus u2 and v2 minus u2 will get cancelled. So the final expression will be u1 plus v1 is equal to v2 plus u2. Clear? Now this can be written as v2 is equal to take this u to the left, that is u1 minus u2 plus v1. Call this as equation number 3. Now substitute this 3 in equation number 1. What you get? I'm substituting equation 3 in 1. So in place of v2 here, I'm substituting the value here, that is value of this one, that is m1 into u1 minus v1 is equal to m2 into, instead of v2 you can write u1 minus u2 plus v1, then this minus u2. Clear? Now if you multiply, that is m1 u1 minus m1 v1 is equal to m2 u1 minus m2 u2 plus m2 v1 minus m2 u2. Clear? Therefore, this will become, take the u1 to one side, that is m1 u1, take this u1 to the left, that is m2 u1 is equal to this minus m2 u2 minus m2 u2 will become minus 2 m2 u2 plus m2 v1, take this m1 v1 to the right, plus m1 v1. Clear? So this can be simplified as taking the u1 common, that is m1 minus m2 into u1, take this minus 2m2 to the left, that is plus 2 m2 u2 is equal to, take this v1 as common, so v1 into m2 plus m1. Instead of m2 plus m1 you can write m1 plus m2. Now call this as equation number 4 and divide the 4 completely with the term m1 plus m2. So this will become u1 or m1 minus m2 u1 divided by m1 plus m2 plus 2m2u2 divided by m1 plus m2 is equal to v1 into m2 plus m1 divided by m1 plus m2. Clear? Therefore, the final expression will be this m1 plus m2 and this m1 plus m2 plus this m2 plus m1 and this m1 plus m2 will get cancelled. I'm writing this one on the left, that is v1 is equal to, this is equal to m1 minus m2 by m1 plus m2 times u1 plus 2m2 u2 divided by m1 plus m2. Clear? So this is the expression for velocity. Velocity acquired by the first body after collision. In order to find v2, you only need to interchange the suffix. That is, here it is m1, you have to write m2 minus m1. See, this one is equal to m2 plus m1, so that doesn't change. m2 plus m1 or m1 plus m2, that both are the same. So m1 plus m2 times, here u1 will become u2 plus 2, here m2 becomes m1 and u2 becomes u1 divided by this thing m2 plus m1, which is same as m1 plus m2. So this is the velocity acquired by the second body. Clear? So these are the two velocities acquired by the body after collision. Now we have to consider different cases, which means what if their masses are equal or one is stationary, all the different cases. So case 1, when the masses are equal. So what happens to the velocities when masses of both the bodies colliding are equal? Suppose we call m1 is equal to m2. Let's say that is equal to m. So what you get v1? v1 is equal to, that is m minus m by m plus m, since m1 and m2 both are equal to m. u1 plus 2m u2 divided by m plus m. So this will be 0. v1 is equal, this term on the left, it is 0. Here it is 2m u2 divided by n plus m is equal to 2m. 2m will get cancelled, so v1 is equal to u2. So what about v2? So v1 is equal to u2. What about v2? v2, this will be m minus m by m plus m times u2 plus 2m u1 by m plus m. So again this will be 0 and this is equal to 2m u1 by 2m, which means v2 is equal to u1. So what do you mean by these two equations? That is, the velocity of the initial velocity of the second body is acquired by the first body. Similarly, the initial velocity of the first body is acquired by the second body. So the bodies just exchange their velocity. Clear? Then let's take our second case, case 2. In the case 2, let's assume the second body is rest. which means the second body is rest, that is its velocity is 0. And let us assume the bodies are having equal masses. So what are the difference in the or what are the velocities, final velocities acquired by the body? So v1 will be here m minus m by m plus m times u1 plus 2m, here u2 is 0, 0 by m plus m. So v1 is equal to, this term is 0 since m minus m is 0, this term is also 0. So the velocity of the first body, velocity acquired by the first body is 0. Clear? So what about v2? So v1 equal to 0. What about v2? v2 is equal to m minus m by m plus m times u2, u2 is 0, plus 2m divided by m plus m into u1. Clear? So v2 is equal to, this term is 0 and this term, this 2m and m plus m is again 2m, this will get cancelled. So v2 equal to u1. So let's consider that case. Just consider this case, that is two bodies of equal masses, these are having equal masses, one is at rest, second body is rest, first body is having an initial velocity u1. So after they collide, let's call this first body and let's call this second body. The first body comes to rest, that is v2 is equal to 0. Sorry, v1 equal to 0. That's what we got. v1 is equal to 0. But the second body v2 is just v2 moves with a velocity equal to the first body. So the velocity at which this body collide with this one is attained by the second body, and the first body comes to rest. Clear? Now for our third case, case 3, consider a light body collides with a massive body. That is, this is m1 and this is m2. So comparing the mass of m2, m1 is very small, m2 very much greater than m1, or we can approximate m1 approximately equal to 0. Also, the second body is at rest, u2 is equal to 0. That's our third case. That is, a light body is going to collide with a massive body and the massive body is at rest. So what is v1? So you can assume m1 as 0. So 0 minus m2 divided by 0 plus m2 times u1 plus 2 m2 into u2 is 0 divided by 0 plus m2. So v1 is equal to, this will be minus m2 by minus m2. So minus u2. Minus u1. Clear? So which means the body after collision rebounds. Clear? The final velocity, this is the initial velocity. Final velocity will be v1 but in the opposite direction. So if this body comes in this way, after collision it will move this way with the same velocity. So what will happen to the velocity of second body? v2. v2, this is equal to m2 minus 0 divided by 0 plus m2 times u2 is 0. Second body is at rest, plus 2, this can be assumed as 0, we took that as 0, into u1 divided by 0 plus m2. Since this is equal to 0 and this also is 0, so v2 is equal to 0, which means the second body, that is the massive body, continues to be at rest, that it doesn't change. It doesn't acquire any velocity. Now let's take our fourth case, case 4. This time a massive body is colliding with a light body. Here m1 is the mass of the massive body and m2 is the light body. The massive body is coming with a velocity u1 and the light body is at rest. u2 is equal to 0. Clear? So comparing with m2 or comparing with m1 is very much greater than m2. So in this case, m2 can be approximated to 0. So if you put all these values in here, this will be m1 minus 0 by m1 plus 0 times u1 plus 2 into m2 is 0 to u2 is 0 divided by m1 plus 0. So this will be v1 is equal to this m1 and this m1 will get cancelled and v1 equal to u1, which means there is no change in velocity for the massive body. It moves with, after collision, it moves with the velocity as as in the beginning. That means it moves with the same velocity it has come before collision. What about v2? v2 is equal to this is equal to 0 minus m1 divided by m1 plus 0 into second body is at rest 0 plus 2 m1 divided by m1 plus 0 times u1. So v2 is equal to, this is equal to 0 and 2m1 by m1 is 2. So 2u1, which means the light body after collision moves with the double velocity of the first body. So the velocity acquired by the light body is double the velocity at which the massive body hits with the light body. Clear?